Hello everyone, very good morning. Revant here.
So, waiting for today's session. So, almost all the students have joined, sir. We can start the session now.
Okay, ma'am. Okay. A quick recap of the yesterday's class. we were we were trying to build a chatbot based on the text analysis or NLP. We almost done the pre-processing part. Today we will work on obtaining the pre-processing output and also training the chatbot and build a chatbot user interface application. Okay, so let me share my screen. I will be using Anaconda today. Sorry, I won't be using Anaconda. You guys can continue using Anaconda. There are some issues on my system opening it. I will open. I will work directly on this VS Code itself to write the code. If you see the folder, so this is the folder that we are currently using. Okay, it is having chat, train, and intents. Okay, so let me run the program that we did yesterday and see if the pickle files are forming or not. Anyone got these two files? Like, did you observe these two pickle files getting created? Words.pkl and classes.pkl. If you're able to see that, let me know. I'm running this program. Okay. The extension is loading and it would print the output. Let us see. Those who are running on Spider, open the complete folder using Spider itself. You can do that by going to click on file on the top left, click on open that file, chat underscore train, and just run the program. And let me know if at all you're facing any issues. If not, it is fine. I will initiate it from Anaconda also. Looks like the VS Code is not responding. So, okay, we will run it later. Let's go with the training part. Means pre-processing is done. Next, what you need to do is you need to take this pre-processed information. Okay, it will take this pre-processed information and we will directly dump it in the algorithm. Okay, so I'll show you how this actually there is a little more pre-processing that we need to do. So uh, I will create a new file now. Okay, okay, this is fine. I think it is running now. Let's take time. Open a new file. Open a new file and write the program that I'm going to write here. So, my Windows got crashed somehow. Okay. Did anyone able to see words.pkl and classes.pkl got created? Those who are able to create, just ping on the chat. So in a new file, in a new Python file, just create a new file in your Spider and do one thing. Create an array called training. This is our training information. So what we are going to do is output training info will be stored here. Okay, a small array. This should be in a new file. Name that file as the file name of that should be chat training secondary secondary training process. This is basically the continuation of the next one, but we are going to put this in a different file. Okay. So training, and also what I'm going to do is I will be creating one more array after training. I will make an array called output for the outcomes. What are the outcomes here? See, an outcome here is nothing but understanding the intent of the user, and accordingly we will respond to the user. Okay, first of all you need to understand the intent, and according to the intent you respond, right? Even the conversations that we make work like the same. Forget about conversations. Even you take the sentiment analysis. If you take the if you I'm sure you use LinkedIn and Gmail. Even there you see automated responses getting generated, right? How do they generate those fixed responses? Those are fixed responses, right? Very generic. Those responses will be stored inside this object or this array. So once you understand the tag of it, you need to go to the tag, pick up this response and send it back to the customer. Okay, customer is the one who's actually talking with you. Okay, so let me show you something. I gave you one file yesterday. You guys downloaded, right? Chat application main. Do you remember? We downloaded this yesterday. Open this file. Okay. Just to reduce the time taken, I gave you the completed project actually. So let me explain the architecture now. So train chatbot is nothing but chat underscore train that we created. If you open train chatbot, okay, this is the code that we wrote yesterday, correct? So we took all these, we did the dumping. Once the dumping is done, there are, we actually created one model. I'll explain you how we created this model and all. So data pre-processing is done. You can open this file. Open this file, train underscore chatbot. I'll explain you the code. So we did that till line number 48. Okay. So by line number 48, it creates the pickle files, and then it is doing some operations here. I'll explain these operations. And after that, look at the outcome here. The outcome is in line number 95, 95 and 94. If you observe this, we are not doing any prediction here, isn't it? So normally how your process is working, normally how your process works, you do the prediction. But here we are not doing the prediction. you're saving a model separately. Okay, with deep learning uh, use cases or case studies, whatever it is, you create a model separately and store it somewhere. Okay, whenever you have the test information, means the actual prediction, you import this model somewhere else. Okay, let me explain it with a block diagram. You'll understand better. This is very important because this way of approach is what you need to follow when it comes to any of the deep learning problem or even machine learning problem as well. I hope you are able to see the whiteboard. So look at the flow that we are currently using. All right. I shared the whiteboard with you as well. You can check. So initially the JSON information that I have, guys, this is the complete flow of sentiment analysis and also NLP related problems. Okay. So I took this JSON and I actually did pre-process, tokenize, lematize. These two are related to your NLP. Next, I did serialization. Okay, information got serialized. This serialization is done by using the dependency called pickling. We imported that as well. Okay. Next, after this, you need to take this information and start another process, that is make training format, import. We already imported, but import deep learning model. These are the next steps actually. Not model exactly, it is algorithm. Next, do the fitting. Dot fit is function for what we already implemented in iris example also. Dot fit is used for training, right? Once the training is done, the difference here is in iris example, as soon as the training is done, we did the prediction. But here we are going to save the model. Okay, this is phase one of, you can actually consider this as phase one process in any sentiment or text analysis. It will become a chatbot when you do the phase two. Phase two you can change. You can do it for a chatbot. You can do it for a email application. You can do it for any reviews related applications. Any use case. Take any use case. Okay, that comes in phase two. So once this model is already available with me, so this is the model that is available that I downloaded. Actually, it will be downloaded because see, you can see it here also. Can you see this chatbot model.h5 in the there is one file. Can you see this, everyone? In the file that you downloaded, there is chat model.h5. .h5 is the extension for the models. Okay, so you saved this file separately. You saved classes.pkl separately. You saved words.pkl separately. Everything is just an outcome of the intents. So data set, from the data set that you got, you're taking this complete information and you're using it. So now in phase two, what you do is you build the model. So this model is a combination of what? It is a combination of algorithm plus dataset. And this dataset was initially in the JSON format. It can be in CSV, it can be in XLS, it can be image, it can be anything. Okay. So I take this model, I import it. Guys, one more thing here is phase two, we are going to use another Python file. You need to create another Python file. I'll show you that Python file. Can you see this new file? There is one other Python file here, chat GUI, chat graphic user interface. We are going to import that in that file. Import in chat GUI.py. Import that. Now here you will build the user interface. See, one more important thing here. If it is a chat application, you build it for in a chat oriented way. How your chat box looks like, how your WhatsApp looks like. In the bottom, there will be a place to text, and there is a send button, and then you send the message. That message should be collected. See, now your prediction, this is the most important part. Once you build the UI, building UI means it is not just what you see, it is also having the functionality. What is the functionality? So whenever a new person sends a message, I'm removing this part. Whenever someone sends a message, who will send this message? The customer or you. When you use Google Assistant, you send that message. Then what it needs to do is, this is the value that you need to predict. What you need to predict? You take this message, you need to send this back to the model. Guys, if you don't understand this functionality, it would be tough for you. You need to send it back to the model, and this model will give a response. That response is nothing but the actual chat response. If it is an email, what will happen? If it is email, then it will compose a small statement which is a responsive. If it is a sentiment analysis based reviewing system, you will understand whether the person gave a good review or a bad review. Correct? So if you take the prediction mechanism, how it will happen is, It will consider the model. It will import it, UI, and this UI will take external input for prediction, and then this will give the response. Okay, that is how the flow works for this complete thing. Now, what we are going to do is we will learn everything in specific, how the model can be imported, which model we use, how to import it, how to build the UI. I will focus more on how to build this responsing system because this is the most important part. Once the model is downloaded, it is fine, but you need to write, you need to do reverse engineering here in getting the response, giving it back to the model that you created, because model is the person who will understand what the customer is sending you in the form of a message, right? So any doubts in this architecture? Okay, no doubts. You can actually download this from your Jamboard that I gave you. It is already shared on the chat. Go to that link. If at all you want to copy this somewhere, you can do that, or take a screenshot. Okay, I'll put it here. If at all you're taking screenshot, you can. Okay. So now, access denied. Okay. Acha. Okay. Give me a second. I will give complete access. I think it is in the private mode. Don't edit this. I'm sharing a new link, everyone. I gave it a public access. So anyone, actually, I was getting multiple emails requesting for the access. Okay. I cannot accept every email. It would be a very time taking task. I made it public. You can check it. Okay. So next, looking at the implementation part, first of all, we will kind of do the continuation for the yesterday's code by taking the training model. Uh, Modeling part we already know, so I will be focusing more on this functionality. Okay, I will focus more on this functionality than training the model, because a lot of people, even when I teach, they face doing a reverse engineering for this problems, right? So let me show that with you. So okay, let me delete all this and rewrite this code. So once the dumping is done, you can go to your chatbot underscore train.py. Once that dumping part is over, listen carefully. Here, training information is getting created by using two arrays, training and output empty. Okay. And we created something called documents. See, what is the format of documents? Print the documents and see how the format is looking. It will be a, okay, let me do that here. Everyone do this execution, write a print statement after this dumps, or you can write it here also, not a problem. Documents. Look at the format of the documents. It will be a combination of messages and also the, you know, this tag or the intent of the conversation, whether it is a greeting or a thanks message or what it is exactly. So I'm going to take a for loop and iterate inside the documents. Why am I able to iterate here? Because documents is an array, isn't it? So I'm going to iterate inside this array of tuple. Inside there are tuple actually, and create a new array called bag. Okay, and then we need to perform another round of uh, lemmatization here. So I will take the another array called pattern words, and I would say doc of 0. What is doc of 0? Can anyone tell me what will be the doc of zero's value every time? So one document at a time, and I am taking the it. This means what? Taking first element in the doc. Okay. Let me execute that here itself. I cannot execute on Notepad++. So okay, let that execute. So this is the first element in the doc, which is nothing but the words. And then what I'm going to do is these words I'm going to lemmatize again. So I'm going to change the value of pattern words by updating the value of pattern words to the lemmatization. Lemmatizer dot lemmatize. What am I lemmatizing with? I will be taking the word dot lower. Every time you need to convert that into a lowercase object for word in pattern words. Means what? So here, what am I doing? Listen carefully. This is kind of tricky. I'm taking the words in the documents. Okay. See, this is how your document look like. Look here. 88 unique lemmatized words that I have. And after that, let me do one thing. After this, I will print some gap here. Else I can't differentiate between all these. So print a gap and run it again. Yeah, let it run. Did you understand this? So I'm taking each and every word inside the pattern of words. That is nothing but, see, observe this. See, the one that is selected now, it is a it is a very simple doc inside the docs. So I'm taking one. This is the pattern words. Okay. Now the value of word will be in the first iteration. The value of word will be hospital. It is taking hospital, lemmatizing it. Taking lookup, lemmatizing it. Taking fur, lemmatizing it. Patient, and it will lemmatize. Okay, understood? So that is nothing but the pattern of words. After this, so here the target is so once this pattern of words are created, so now I'll tell you what exactly we are trying to do here. These are for each and every pattern, I'm lemmatizing it. Pattern is nothing but the kind of conversation. This is a hospital search related conversation. Okay. And the other selected one, see this one, how to check adverse drug reaction. Means some customer is texting the hospital that I took a drug. How to check that it is adverse? It is giving me some side effects or something. I categorized it under adverse underscore drug. That is the category. Okay. So next, so let me continue writing the code here itself. This is the pattern, and I'm going to make another loop here. What is words? Words is nothing but that huge array of all the words that we got, right? So here I'm going to do something that is for W in words. I will be creating, look here carefully, bag dot append. What is bag? It is an empty array, right? I'm going to add one to it. When I will add one is only if W in pattern words else means what? See, I reiterate inside words again, and I will see in every pattern whether this word is existing or not. Okay. So what will happen? This words is already lemmatized, and I lemmatized each and every pattern based on the tag that I attached, and I'm finding whether this word is related to a particular tag or not. That's it. If it is related, if it is existing, then I will add one to the bag. If not, I will add zero. One represents it is present, zero represents it is not present. So if W in pattern of words, else I would add bag dot append zero. Okay. So after that, I will write output underscore row. The row of it is equal to the list output empty. I'm just creating a list value here. We will see the output now. And every time I will be taking this output row and I'll put the index of it as 1. And after that, the training array that I created on the top, line number 51, I'll be making the training array in such a way that it will be a combination of whether that word is present or not. Means every time I'm making a multi-dimensional array here, the bag of output. Actually, this will you will understand when you execute. Let us see the kind of output that we get here. So, what will be the final format of the training information? It is nothing but a multi-dimensional array with the output of bag and the output of this output row. These both. Okay, they will just represent a particular word is belonging to a particular pattern or not. That's it. And it is just a simple binary format. If at all you see, do one thing. After writing this loop, print training. Okay, what is it saying? The list index is out of range. Okay. Oh, okay. Actually, this should be out of this loop, I guess. Just a second. Doc1 should be accessible because doc0 is available here. Equal to list assignment index is out of range. cannot be out of range, right? Oh, okay. This is output row. Run it again. Okay, let me do one thing. I think it should be out of this loop because the bag value will be available at once only, right? So it should be out. Run it again. It must be some syntax error. Let me just correct the code. Okay, I did some syntax error maybe. So if you see, you will get one huge pattern where, so what will this indicate is if there is any word which belongs to the pattern which got repeated maybe, so you just take all those words and create indexes whether they are present in the bag or not. Okay, that is how, this is how your training information output will look like. Okay, all right, so that is my training info. And here, as I told you, your training information should always be shuffled. Okay, so I'm doing if you remember, we imported something called random in line number 11, right? So the reason for that is I will be doing a random shuffle here. I'll give you the code at once. You don't need to write it. Just listen. Random dot shuffle training, and I'm going to convert this into a number array because if you observe the format of it, the array that we are currently using is what it is in the numbers, right? It is not a combination of a string or something. Whenever you are giving any array to a model or to an algorithm, most of the times it should be a numpy array. Okay, because most of the models will support numpy only, and they are actually built on numpy. So most of the machine learning models are built on numpy when they deal with numbers or binary. Mining is equal to, I'm converting this randomly shuffled information into this training itself. And then I'm going to bifurcate into two different parts, train X and train Y. Okay. The reason for this is because this conversion is because your training algorithm will support only this information. And next, you need to build a deep learning model, which is nothing but your artificial neural network. So in an artificial neural network, whenever you are importing the model, And the kind of algorithm that we are using here is a sequential algorithm from Keras. You guys installed Keras, right? Previously, I shown you how to install Keras and all. So get Keras, get it installed. Let's do one thing. Let me send this edited code with you. Don't use the code that I shared in the file. There are a few bugs in it. You can run the code that I am giving to you. Okay. I sent you one link for the code. Just take the code and run it once. You will see this binary output for the training. Check this binary output. If anyone is getting errors, let me know. If you are still getting the Keras error, probably you failed to install Keras that library in the start. That could be the reason. If anyone is getting error, just let me know. After this, we will actually configure the sequential model and create the prediction functionality. The prediction functionality is the most important part here in a sentimental analysis. It is not even creating the model because uh, you just need to configure a generic model and you need to configure your artificial neural network and that's it. You don't need to do anything. Give the training information, model will be created. But how you get the response, you need to grab the response from where? From the customer, right? How the customer is talking to you. So normally you will write an API. Okay. uh, you write a So in scalable applications, how you do that is you will be having a chat client. I'm telling you the actual real-time implementation. You need to create a chat client. That chat client should be sending a post API call. You can actually do this using Django framework on Python, Django plus Python. You can use JavaScript also. You just need to make a post API call, and you will put this. You'll take it in a server, and the server will send this information to the model. Model will do the prediction prediction of the intent. Once the prediction is done, it will throw the response, and this response will be sent again to whom? To the chat client. When actually this is not a post call, this is a get call. This processing will be done, and this will be sent as a response parameter or a acknowledgement parameter. That is how your high level architecture works. If at all you're using a database and connecting it to it, all this code should be deployed on a server and on a database. I can explain that, but it would take nearly 10 hours to do that whole process, because you need to set up a server, you need to set up a database, you need to collect the values from it, and all that. That is a pretty big process. I'll give you some options here if at all someone want to try to implement it. Actually, you can create a chatbot for your own college by using this. Your college may have uh, your own server, so you can deploy this code on the server and you can create it. You can actually do it with mean stack, or you can do it with lamp stack, or you can do it with Python plus Django, or you can do it with AWS. AWS is cloud. Let us say your college server is not sufficient, it is not capable of handling this much of information. Then you take AWS cloud or Google cloud, and on cloud platforms or Azure, this comes under your cloud computing. It's very simple. You don't need to implement cloud computing concepts and all. You just need to connect your server onto the cloud. It is serverless, right? Normally, but you write the functionality, and on AWS you can write the functionality either on Python. You can write it on Node.js. You can write it in JavaScript. There are various different options. So the server related code will be written over there, and in database, what do you keep in the database? Your training information will be in the database, your model will be in the database, your pickle files will be in the database, and the chat client will be either available on a mobile phone. So to make it, you need to develop an Android application or a iOS application, or you can actually create a desktop application on Windows. So we are going to create a desktop application. That is what I'm going to teach you now. For mobile, again, I need to brush up your Android knowledge again. So I'm not touching these for now. But if at all you're interested, you can actually use this. And one more thing is, you can actually do this whole process on Java also. But it won't be that efficient. You can implement this whole thing on Java. With Java, the easiest part would be your Android application would be developed in Java. Your APIs will be written in Java and everything. So this is how the entire technology stack will work. And if at all you're able to implement all this will become a full stack machine learning chatbot application based on sentiment analysis. Okay, that would be the name of your project if at all you are implementing it. Okay, so this is the tech stack and real-time implementation. This is the base implementation. Okay, the internals of the deep learning model. All right. So now I will show you what to write in this server code, what exactly and how exactly you need to take these responses by building the chat client. So as I told you, we are going to create this desktop client. Okay, this desktop client will be created now. So we will see how to do that. So once the training model is done, you can actually check in the code itself that we will be using the sequential model to create. This is a default configuration that we are going to do. First, import the sequential model. For sequential model documentation, I will send you. You need to understand the artificial neural network. I'm showing you the implementation part. You go through the concept and how exactly the underlying concept works, because we have two more assignments to solve now. Image classification and one more example just like this. So you can actually configure this model by adding the density and everything. I'll show you the configuration part here. This is the configuration that you need. You can actually use this generic configuration everywhere. Not a problem. Okay, it will work. Once that is done, you do the fitting. Fitting is nothing but training, and model will be created by here. Line number 88, the model will be created. In line number 91, 92, and 93, it will save a chatbot model for you. Okay. Don't execute now. I'll show you the execution part. If at all you want, you can do that. Not a problem. I'll send this code to you. Use the code that I am sending. Don't use the code that is already there in your documents. Check the link again. I shared the code. Okay. So this is done. The training and the analysis of the data and fitting is done. Now, what we are going to do is how to do the prediction. Prediction is a very big process now. So I'm going to create a new file, a new Python file. Please create that. Okay. Now, this is the crucial part. Even here, we are going to import NLTK. We are going to get the same libraries that we used before. Please import those. NLTK, Lematizer, Pickling, and NumPy. All these. Because you need to do the process in reverse now. Okay. Means taking the message sent by the customer, lemmatizing it, compressing it, and then you feed this to the model. Okay. So this process is totally reversed now. All right. So let's look at that. So next one is Keras has a functionality where not only just creating a model, but you can actually load a model, because the already created model, if you see in the last program, we generated the model here that will be saved. Here you need to import that. Okay. And the model that I'm going to use is load model, and the name of the model, this name should match with this name. So I'm using the same name here because that is the model that I generated. And import JSON import random, and then you also need to load your, see, if you remember in the previous program, guys, you don't write the code, just listen to what I say. In the previous program, to get the intents, I did two steps. I opened it and I sent here. Now I did that in one step. JSON.loads, I'm opening directly here itself and reading it. So the intents, the format of intents now, the data type for that will be dictionary, the JSON dictionary. And using pickle, I will load the words and also the classes. So previously I'm writing the information, now I'm reading the information. RB represents reading the information. So I will read the information and store it in words and classes. Okay. So now the reverse engineering part should happen. The first thing that you need to do is, what is ultimate goal here? Well, let us come from the back to the front. Okay. Listen carefully. What is the ultimate goal? You need to create the chatbot's response, right? Chatbot should respond to you. Whenever you say hi, it should give response to you. And what will it take? So this is how you write a function. I think we never wrote a function till now. I'm doing a function declaration plus initialization here itself. A chatbot response, it takes something called a message as a parameter. Okay. And the final outcome is to predict the class, right? If you take the iris example, what we did in the last, this is the iris example. What we did, this is the reason why I explained you people this, the basic one. You took a input from the external end and you did a prediction, right? So similarly, see, this prediction is basically so this dot predict function, this is an inbuilt function. But here I'm going to write a custom function on my own. So ints is equal to predict underscore class. Why predict underscore class? Can anyone explain this? Why am I predicting the class here? What is the purpose of predicting the class? I already explained why. And if at all I predict the class, what will be the output? Like, what should be the outcome of this function after the prediction? Any idea? Predicting the class means, so if you see the training part, the prediction here, see there is a direct class here. We wrote classes here. And this class is nothing but the type of conversation, whether it is a hospital search or pharmacy search or what it is exactly. Okay, just a second. Okay, let's break for 5 minutes and come back. We'll go with the next part. Okay, just get back after 12:16. Okay, everyone. Just let's get back. So, predict class is going to be a custom function. You may not see. This is not a inbuilt function at all. So, I'm going to predict this class, and then finally, I should get. I basically need to write another function also, which will give me the response based on two things. One is, see, I'll predict the class by taking the message and also the model. What is model here? The model that I imported. Okay. Take this message, take this model, and to get response, ints is going to be one variable that I'm going to create, and intents. And finally, I will return a variable called response or res. This is the final response from the chatbot for every message people send. Okay. Now the question is how to get the response. So as I told you, we are going to reverse engineer this. I'm going to create one more function and see how I can get the response. It is passing two parameters here, ints and intents. So I will take the ints here and intents underscore JSON. That is a JSON information. So, and then I'm going to do something here. Listen carefully. This is the important part. I will first take the tag of the intents, ints of 0, and the actual intent of it means with what intent the customer is actually talking to me. What is his intention? That is important, right? Okay. So that is the intent here. And then I will take the list of intents. And what I'm going to do is I'll match the intent that customer is sending me, and I will find out. See, this is just a matching algorithm here. So let me show you. So once I find out with what intention the customer is talking to me, if that is matched with the tag in my data set, then I will take the response from that particular object. Let us say the customer is saying hi, or let's say he's saying bye, and it matched with the pattern. Then from the same object, I will take a response. I'll take randomly. So basically, I can select randomly, right? There is nothing like I should say see you only, correct? So I'll take any of this randomly, and I will revert back to that person. So I'm going to do the same. So let us see how to write it in the code perspective. So the list of the whole list of intents will be stored in the intents of JSON is what? The actual JSON file. Okay. So just a second. What is this intents? The actual JSON file. You already have it. So I'm taking that. And to identify what you need to do, this is just a simple search algorithm, searching and sorting. You would have done it in almost every programming language. So for I in list of intents, if the tag that I have, list of intents is what? The list of all the intents that I have. And if any tag of it is matching with the tag in this, then see here, then the result would be, the result is what? The response. And if you observe, the result would be chosen from randomly from the responses variable. So result is equal to random choice inside the responses. Okay. And then once the result is chosen, I just need to return that value. I can actually break the statement, right? I don't need to search anymore. So I am breaking the loop here. And then I am returning the result. And where will this result come and sit? Which function is calling it? Line number 43 is calling it. So the return type of this function will be assigned to res. And that response will be the response that we will send to the customer. That's it. Okay. So now, how do you predict the class here? That is important, right? How do I predict the class? If you observe something, you're missing something. What is INTS? How do I find INTS? How do I find the intent of the customer? That is the first thing that I need to do. So now let us create function for the predict class. F predict class. What is it taking? It is taking the message from the customer. You can actually name it as the sentence from the customer and the model. The model is nothing but the chat underscore bot model that we created. So I take those two and I will use it to identify the class of it. So this is where I'm going to do the prediction. So I'm making a simple value p, and there is one function called bow that I'm going to create. This is also a custom function that we are going to implement in the upper portion. Okay. So bow will take two things. One is the sentence that the customer is sending, the words that we have, and there is a default configuration that you need to do that is false. I'll tell you why exactly we wrote it. When we write the function bow, we can see that. And the response will be model dot predict. So here I'm doing the prediction. I'm doing the prediction based on np dot array. Okay, and I'm taking this as p. What is p? P is bow of the sentences. So now what is bow? Listen here carefully. This is very interesting. Bow is another function that I am going to write, which will take the sentence, will take the words, which will take a simple flag item, that is show details is equal to true. This is a Boolean expression. Okay. So here we are going to take these values, and what I'm going to return is I'm going to clean up the sentence. So sentence words, because observe something, your deep learning algorithm will not understand the words, will not understand the sentences. It will understand only the words. So I'm going to take the sentence and I'm going to write clean up the sentence, and I'm passing the sentence to that function. Guys, this is the same procedure for your sentiment analysis also. You need to do the same. And you take a bag and you create that bag here with length of number of words that you have. For s in the sentence words, what I'm going to do is I will find out whether these sentences are in which bag, to which bag these belong to, and each and every bag is, see, listen here, I'll show you the functionality here. So what you need to do is you have documents, remember, the previous array that we created. How is documents? Hi, hello, and all. I'm giving you one example. And it is having another parameter called greeting. Okay. Now, my customer sent me hi. Okay. So I actually converted this array into greeting, which is nothing but a class. And I'm also checking, I also have the information of whether hi is present, hello is present or not. Okay. So when the customer sends me a hi, what I will do is I'll compare it internally. This happens internally. It will compare this with to which set does this belong to. So it will identify, okay, this hi is related to a bag called greeting, and that greeting is nothing but the class. If you identify the class, that is what the functionality here, right? You just need to identify the class, and that prediction you will send it to the function in line number 31. Okay, so for s in sentence words, I will take this array in enumerate. Can anyone tell me what is the function enumerate do? The basic Python function. If the word is matching with the sentence that is broken into multiple parts, means W is the word that the person sent, S is the word which is in the bag, right? Then it will say, it will make this bag element as 1. 1 means present. If at all that is present, and if at all you want to show the details, Show details is what? True. The value of show details is true. Okay. So actually the reason why we kept that is it acts as a flag actually. If you want to show the details, you can show. If you don't want to show it, you don't need to show. Basically, this is not even needed to write, just to make it more comprehensive. Okay. So so print this found in the bag means that word is belonging to a bag of a category. Okay. If you want to print, that's fine. Basically, let's remove it. It's not needed. I just identify the bag and then I would return an array of this particular bag. So what will happen now? P is what? Now P is the bag of elements. So it will take the small bag and compare that with the model. See, this np dot array bag, this value is assigned now to P. P is given to what? The prediction model. Then I will obtain the response by putting a error threshold value, and I will return a list of values here which will predict the class of it. Okay, just by sorting everything together. Okay, so all right. So now I'm going to take the bow here, and after this, if you observe something, bow is doing what? It is cleaning up the sentence. So what does cleaning up sentence mean? Cleaning up sentence is nothing but, you guys already did this, you know this, is nothing but a combination of lemmatizing the word and taking the sentence of the words. Now see, now reverse engineer. So I need the response. So I predicted the class and I got the response. So first I predicted the class, gave that information to get response. And to predict the class, I need to identify the to which bag this sentence belongs to, so that I can identify the intent of it. And to do that, I need to break it into words and clean up the sentence by lemmatizing it. I tokenized the information and I lemmatized in line number 15 to line number 20. So from there, I will obtain the response here. Okay, that is the flow. If at all you want to do it for a review system, you tell me what will change here. Do you think anything will change here? No, right? Let us say you are applying sentiment analysis on reviewing system of Google. For example, what is your value of MSG? MSG is nothing. See, now that is the reason why I had to stress on this project a lot, because once you know this project, once you're able to implement this project, you can replicate the same for, I'm telling you, at least 200 different projects, because just the use case changes, right? The sentiment analysis use case changes, but ultimately the core concept is to identify to which class or to which intent this particular sentence belongs to. That's it. If you increase the number of chances in the data set, let us say you're implementing a review system in Zomato. Okay. So there the classes will be, okay, the person liked the restaurant, the person hated the restaurant, the person had a bad experience with the dish, the food is not hygienic. So you need to prepare that data of that JSON information, and based on that you need to implement it. Nothing changes. You just need to change the data set. That's it. Change the data set, change the message that you're giving. Rest all is the same. As simple as that. Okay. Any doubts here regarding the implementation? If you have, you can ask. Meanwhile, I will show how to implement this in other projects. I'll list it out. Sentiment. This is sentiment analysis. So you have the existing engine of the model. Okay. What all you need to change is, I am mentioning it in green, the data set must be changed. Let us say you can have a data set for, sorry, review system, data set for email responses. Okay. You tell me more cases. In where else we can use the same? Can anyone, if you have any ideas, you can share those ideas here. You tell me, this project can be implemented where? The sentiment analysis project can be implemented where else? Chatbot I also already mentioned. And what? Think of them. Think of them and send it in the chat. I'll add that list here. And to this engine again, you need to give the, you need to collect the response from either a Android application, if at all you're doing it from mobile, or an iOS application. This is the MSG parameter. You just need to change this parameter. That's it. And or you can take a desktop application, or you can take a website. You can integrate this into website, or you can integrate it to a Facebook Messenger. Just the way you take the messages will change. You can integrate this on WhatsApp. Wherever you are generating the text information, that information you must be able to collect, and collecting that information will be easy with Python, right? And coming to this data set, the format of this data set can be in anything. The top formats would be, the preferred format would be JSON or CSV. If at all you are making the data set, if at all you're downloading your data set, you can do it here. And also this data can be of any language, but you just need to make sure that the key values, sorry, the key names must be the same. Let us say you're trying to implement any project now on the sentiment analysis. what you need to do is take the JSON file. uh, okay, bring this JSON file here, add more number of rows, add more number of diversify this. See, these are the various different classes that I have: greeting, goodbye, thanks, no answer, options, adverse drug, and all these. This is for a hospital. You prepare a data set for various applications. For example, mail, please find the attachment. Let's say you write please find the attachment, then you can actually convert that and identify the class of it. Okay, so next, okay, this data set would change, and engine and everything, even the code is also the same. The code that I shared with you, that is also the same. Only the intents file will change, pkl files will change. That's it. Rest all remains the same. One more other change will be, so once I get the response, now the question is, the biggest question now is how to get this message msg. Where will I get this from? Okay, so that UI part, I'll discuss in the next portion. If you have any questions, you can ask me now. I'm opening the session for doubt clarification. Or if you are getting any, okay, sorry, I forgot to send this code. Let me send this code to you. Just execute this code. You won't get any output because actually I'm not sending any output here. If at all you're getting any errors, let me know. That's it. Don't expect any output. Just mention the errors that you're getting. Check the same link. The code is shared there itself. Check the link that I sent you. Do the execution. Don't delete that downloaded file. I gave you one file, right? Those this folder, chatbot application main. Don't delete these. Keep these because you can use the same code to build any kind of project. Okay, so just put it, train chatbot and chat GUI. Chat GUI will change a little bit. Train chatbot will not change. It is the same. Intents will change because your data set will be different for a different application. Rest all will remain the same. Okay, if your
Shall we
code
wait
is,
for 10 minutes?
yes ma'am, yes ma'am, yeah, continue.
Okay. Students, any questions? Okay, sir. We'll break for lunch and we'll come back at 2 o'clock.
Okay, ma'am. Yeah. So just execute the code, everyone, and let me know if you are facing any issues. You can just ping me here. Let's break for lunch and get back at 2 o'clock.
Okay, sir.
Okay, ma'am.
Thank you.
Yeah. Yeah. Thank you.